Okay, can you all turn on your videos, please? Okay, so the plan for today is do the homework 2 discussion on geometry, and then continue along with geometry. A few more topics are there, and then time permitting, I think there should be time to do a bit of number theory as well. Recording is happening, right? Let me just see. Yeah, all of you able to hear me well? Veer is there. Veer, is your audio okay, beta? Can you say something? Oh, still same thing as last week. I'm sorry. I don't know, something on your side. Okay, fine. But yeah, so as long as you're able to hear me, that's at least good. But I spoke to mom. She was going to fix it for you this week. But anyway, just check with her once later. All good. Otherwise, Navya, you're okay? Okay.
Yes.
Before we start, any opening questions on anything that was not clear, or you want me to go through anyone? Anything at all? You apart from the doubts regarding the homework, which we'll come to, but any bothering questions, any itching questions?
Sir, question 6.
We'll discuss the homework problems. We'll discuss. No problem. But other than that, anything? Okay. All right. I'll take that as a no. Let's discuss the homework questions then. All of you bring up your own PDF, but I have it here as well. I'll keep pasting it as well. Okay, isosceles triangle has sides PQ and PR. So in the interest of time, what I'll do is, rather than go and ask each of you, did you do this? Did you do this? Occasionally, I might just ask a question. I'll do it all, but you can just self-correct yourself. Okay, and then we'll see how we go with that. Okay, so this one says isosceles triangle has PQ and PR, each measuring 17 centimeters. Those are the two equal sides. The altitude to QR. So let's draw a diagram. So let's say this is PQ. This is PR. Okay. Altitude is 8, right? So I should have drawn a more flatter diagram. That's fine. When I start, so actually this is the problem, right? When I start drawing a diagram, I won't know. So it'll take 1 or 2 attempts to draw a good diagram for geometry problem. So let's do that. So this is PQ, because it's a flatter diagram, because the altitude is only 8 as opposed to this being 17. So this is 17. So this is what happened here now. Okay, so this is, this is 17 and this is 17. There is the stuff and there is this triangle. And this altitude is given to be 8. So this is 8. So immediately we know 8, 15, 17. That's 10-second time saver. If you didn't know that 8, 15, 17 is a triplet, you lose precious 10 seconds. And that's a lot, right? Collectively over every problem, all of these precious 10 seconds count a lot, okay? So 8, 15, 17. Now, what do we want? We want the area of the in circle. So let me first, just to recap again, right? In the exam, you'll do fatafat. You won't do all of this, oh, nice, pretty diagram and all that. This is only for explaining. I'm taking time to explain it in detail, right? So the in circle is the one that's sitting here inside, hence the name in circle, right? So this will have a radius, and that radius is the in radius, in circle ka radius. And if you recall, that was delta upon S. Delta is the area of the triangle, and S is the semi-perimeter. So semi-perimeter is how much? 17 plus 17 plus 30 at the base, divided by 2, which is 32, right? So, yeah, 32. Again, if you see me doing some silly mistakes, please stop right away. Yeah? Please don't wait till the very end. I am prone to doing silly mistakes because see, I don't have the exam pressure, right? So I'm okay. But you guys, when you take an exam or do the homework, do it very carefully. Okay. So 32 is the 32 after doing the divide by 2, it's 32. Delta is the area. So area in this case is how much? Half into base into height, which is 30 times 4, which is 120. So 120 upon 32 is the in radius. So let's check how much is this approximately. 8 goes 4 times, 8 goes 15 times. So 15 by 4. Okay, approximately 4. The reason I always keep emphasizing on approximately is if you do some mistake, right? some blatant mistake, you should be able to catch it. For example, let's say in this semi-perimeter, you forgot to do the divide by 2, let's say, right? So the wrong working, let's say you did 64, you forgot the divide by 2, you did 64. Then your answer would be 120 by 64, which will be exactly half of 15 by 4, right? You'll get 15 by 8, which is approximately 2, right? Now, look at the diagram. I've drawn a reasonable to scale diagram, which is why it's always important to draw a reasonably scaled diagram. Again, don't spend a lot of time. We are not here for ultra precision, neatness, and all that, right? We don't have marks for it. But a reasonably, in fact, when I started drawing a diagram, I drew like this. I could have continued here also, but just that this does not look like 8 when this looks like 17, right? So that'll prevent me from catching many obvious mistakes, which is why I draw a reasonable diagram. Now, in this reasonable diagram, this radius looks, I don't know the exact value, but 4 seems reasonable, right? But 2 does not seem reasonable, right? Because if the altitude is 8, 1/4 of 8 would be this length, right? Sorry, 1/2 of 8 is this length, which is approximately the radius. But 1/4 of the altitude is only this much. This looks too small for a radius. Okay, so these are small things you should pay attention to. So right now, back to 4. Radius is 4, and now delta by s is, sorry, 15 by 4 rather, 15 by 4, and then you want the area of the circle in the form pi into k. So it's pi into r square. So pi into 15 by 4 whole square. So the k that you're seeking here is this 225 by 16 times pi. All of you okay in this? Ranveer, why is your video off? Turn on the video, please. All video should be on, unless I hear from your parents saying some network is down or you're traveling, this, that, right? I need that information from your parents. Okay, all right. That was question 1. I'll keep going. If anyone has a doubt, please stop me, guys. Okay, I don't have to prompt you guys to ask. By now, you should be able to freely stop me. Okay, question 2. Triangle AOB is right angled at origin. Right angled at origin. So let's draw a diagram here. So this is, and the coordinates of A and B are given 0, 5 and 12, 0. So let's plot 0, 5 would be somewhere here. Let's say 0, 5. This is point A, and then 12, 0 somewhere here. Again, very approximate, just sketching, right? 12, 0. You don't have to take a scale and measure and all that. Okay, and find the coordinates of the orthocenter. So first, let's complete the triangle. So this is the triangle. This is the triangle. Okay, now orthocenter is what? Orthocenter is the meeting point of the altitudes. Okay, so the altitude from A to BC be the line AC itself, right? AC will be the perpendicular coming from A to C, right? I'm not able to draw this on this, but it will be right on the blue line itself. Similarly, BC would be the perpendicular going from B to the side AC, right? And the perpendicular from C to the perpendicular from C is this guy, right? There is a precision problem in my mouse, which is why this is happening. I'll try to fix it. Okay, so essentially we can clearly see that the meeting point of all the altitudes is right at the place where the right angle itself is. So C is the meeting point, which is nothing but the origin. So fairly simple question, right? Cool. Question 2, that was. Question 3. Okay, bisector of angle X intersects YZ at D. So I didn't say triangle XYZ, but I mean it. Okay, let's draw a diagram. Whenever you draw a general diagram, try to draw it like a scalene diagram. Don't draw an equilateral triangle. If you do, then you might wrongly fall into some traps. You'll assume a few things which need not be true. So always draw a scalene triangle to just emphasize it's a general diagram, unless of course the question itself says it's isosceles or equilateral. That's a different issue. So always draw a scalene triangle. Now in this triangle, what's happening here? X is here, Y is here, Z is here. Now the angle bisector of X meets YZ at D. Okay, so let's draw the angle bisector. Angle bisector is like this. So one important property you know is it divides the base in the ratio as the XY is to XZ, the same ratio. And the length of XY is 75% of xz. Okay, so let's say, which means this is xy, let's say this is 3x, then this is 4x. 3:4 is 75%, right? So 3x and 4x are the ratio. In fact, let me not use x, because x is supposed to indicate the side length of the side which is opposite to capital X. I'll use a or something which is like neutral, right? So let's say this is 3a. We know in this diagram there's no a at all, so I won't fall into traps, because small x technically is the side opposite to capital X, which is why I want to avoid small x. Okay, so this ratio is 3:4, but you also know that this ratio is also 3:4 because of the property, right, of angle bisector. If this angle is getting bisected, one of the properties was xy by xz will be same as yd by dz. That was one of the properties we saw. Okay, so this ratio is 3:4 in the bottom as well. Now I say the length of xy, sorry, the median from x intersects yz at E. So there's one more diagram, which is median. One more line, sorry. So this is median, which divides into equal parts. So that meets it at E. Okay, now measurement of DE. That's all we want, right?
So what does median of x mean?
Median, where did I say median of x? Median
The median
from x.
Yeah.
Yeah. Median from x. Median from x means from x to the opposite side, right? Median means what? From a vertex to the midpoint of the opposite side.
Oh, okay.
That's what the median. It's not the statistics wala median.
Yeah.
The geometry wala median.
Yeah.
Okay. So median is the line connecting a vertex to its midpoint of the opposite side. So now we want DE, fairly easy, right? So we know YE is 7 because half of 14. This length is 7. And then this we know is 3:4, right? So this part is to this part is 3:4. So we just have to split. 1 second, Navya. I'll be just with you in a second. Unless you, yeah, go ahead, Navya.
How do you get x, y is 3a? Wanted we 3/4a?
Yeah. I'm just saying 3:4. That's it. So I can assume this to be 300A and 400A. I can assume this, like you said, 3/4A and this is A. That's fine. I can either call 3/4A and A, or I can call it as 3A and 4A. Doesn't matter, right? The ratio 3:4 is what matters. Or just for fun, I could call this 3000A and I could call this as 4000A. All of them are equivalent, right? Okay, right. Now the same ratio 3:4. Now the base entire length is 14. So I'll have to split 14 in the ratio 3:4. 3 plus 4 is 7. So each part is 2 parts. So this will correspond to 6. This will correspond to 8. So which means this length is 6. Sorry, this length is 6. This length is 8. And DE therefore is the difference, which is 1. Does it make sense? Now you got 1 as well?
I didn't understand this.
Okay. Which part did you not understand?
How did you get the length 6 and 8?
Okay. What is the main? Okay. You understood that the angle bisector splits the opposite side into the ratio as the two sides. You understand this one, right? This relation.
Yeah.
Okay. Now the YZ is given to be 14. So 14 is 3 parts, right? Sorry, 14 is to be split in the ratio 3:4. So I'll just do it again. So this is, let's say this is 3B and this is 4B, right? From here to here is 3 parts. From here to here is 4 parts. Is that okay, Drishit?
Yeah.
So I just want to divide 14. And how do you divide a number into some ratio? You'll say the total is 7 parts. 7 parts is 14. Therefore, 1 part is 2. And therefore, 3B will correspond to 6. 4B will correspond to 8. Right?
Oh, yeah.
As simple as that. You're maybe overcomplicating it. Yeah, fairly
Yeah.
easy only.
Okay.
Okay. We're all okay now? All okay? You're able to follow, right? It's fine. Forget the audio. Yeah. Cool. That was question 3. Let's move to. Oh, this is from my previous class. Question 4. Triangle PQR, angles PQR are 30, 60, 90 triangle. Okay, so it's a 30, 60, 90. Immediately you know the ratio of the side lengths, right? If you have a 30, 60, 90. In fact, let's do this here. So if it's 30, 60, 90, the ratio of the side lengths is 1:√3:2. Now, which is which is the one which is 30, P is the one which is 30, and Q is the one which is 60, and R is at 90. So the diagram is like this. Okay, and the side small q means what? The one opposite to capital Q by definition, right? By convention and definition. So this is given to be 10. Okay, now find the circumference of its circumcircle. What is circumcircle? Circumcircle is something which you are able to draw around this, right? This would be the circumcircle. If I can draw this well, right? This is the circumcircle. And that circumcircle has a radius. That radius, unfortunately, okay, I'll just call it, I don't want to call it R, capital R, because we have capital R here. I'll just call it X, right? That radius, if you recall, was ABC by 4 delta, or in this case, the three sides are PQ and R, right? PQR by 4 delta, right? Where delta is the area. Now, which means we need to first find the sides for us to come to the radius. This is the radius of the circumcircle. Okay, so this is 10. Now we know that the ratio of the three parts is x is to x 3 is to 2x, right? 1 is to root 3 is to 2. The one opposite to 30 is one part, right? So now we know that x root 3 is 10, which means x is 10 upon root 3. So this is 10 upon root 3, and this is 20 upon root 3. Okay, now, so we know the three side lengths, small p, small q, and small r. Let me substitute. So one of them is 10 by root 3. I'm not directly putting one to each other. Okay, so small p is that, small q is 10, and small r is 20 by root 3. Whole upon 4 delta, 4 times. What is area? Area is half into base into height. So this is 10 by root 3, and this is 10. Height is 10 by root 3, and the base is 10. So whatever that is, right? 50 upon root 3. Okay, so 50 upon root 3. Okay, so let's multiply and see what we get. So, so let's look for some cancellations. 10 times 10 is 100, which cancels off with this 50 as 2. I could either cancel the root 3, or I could do one of two ways. I can multiply the two root 3s to become 3. So in the numerator, I have 20 upon 3. And in the denominator, I have 8 upon root 3. So it goes up as root 3 upon 8. Okay, I can do further cancellation here. 4 goes 2 times, 4 goes 5 times, I believe, right? So it's 5 root 3 upon 6. 5 root 3 upon 6. Am I right? ABC by 4 delta. Okay. Now I'm suspecting I did something wrong. How am I suspecting? Because just 1 second, Ranveer. This is 5 times 1.7 by 6. 5 times 1.5 is what? 8.5. 8.5 upon 6 is how much? Approximately 1.4, right? The radius of this circumcircle definitely looks a lot bigger than 1.4, correct? So I've genuinely done some mistake, right? Now let's spot what the mistake is. Unless can someone has someone already spotted what the mistake is? Anyone? Anyone has spotted the mistake? Half into 10 into 10 root 3. 50 by root 3. By root 3.
So how did you get 50?
No, 50 was fine. When I canceled the 150, I put the 2 on the bottom instead of top. Okay. Okay. How did I get which 50? This 50, right? This is 50 by root 3, right? Half into base into height. Half into base into height is this. Yes. Who was that? Who asked 50?
Sir, I asked.
You yeah. Okay. All right. So the mistake I did was when I canceled the 100 with the 50, I should have put the 2 upper, not niche. I should have put it here. Mistakes happen, but you should be able to catch your mistakes. We are all human, right? It's one thing to do mistakes, but it's another thing to catch those mistakes, right? So my answer effectively will become 4 times, right? Because the 2 should have been in the numerator instead of the denominator, right? So I don't want to rework all of it, but okay, fine. Let's rework it. It's okay. It hardly takes a second, right? So this 2 is in the numerator. So I have 2 times 20, which is 40 by 4, and then root 3 upon 3. Is that right? Yeah, something like this, right? So which is 10 root 3 upon 3. Earlier we had got 5 root 3 upon 6, right? The 3 had gotten falsely multiplied by the 2 instead of 10 getting multiplied, right? So which is why it differed by a factor of 4, which is why it's good to have a sense of numbers. What did I have earlier? I had 5 root 3 upon 6, right? So root 3, so you will know you don't have anyone to tell you it's wrong. So which is why you need to do this approximation. Root 3 is approximately 1.7. All of you should know this, right? 17 square is 289. 17 square is 289. If you know all the perfect squares till 1000, we know 17 square is 289. Therefore, 300 square root will be approximately 17, right? You don't need to know the second decimal. If you know the fantastic, at least first decimal. 1.7 is square root of. Therefore, I have 5 into 1.7 upon 6, which is 8.5 upon 6. 85 upon 6 is 14. Very approximately, don't waste too much time. 1.4. 1.4 looked wrong to me, which is why I suspected and looked at what mistake I made. And now the answer is 4 times that. The correct answer is 4 times that, 5.6 approximately, 1.4. And that seems reasonable, right? In fact, it should be roughly around half of the hypotenuse, right? Right? Roughly around half of the hypotenuse. In fact, the radius of the circumcircle of a right triangle will be exactly half of the hypotenuse, right? Which I'll show you in just a second. I need not have done all of this, but it looks half of the hypotenuse. Agreed? Just visually, it looks half of the hypotenuse, and visually 5.6 is roughly looking reasonable, given that the base is of length 10. Ranveer, sorry, you had a question?
Oh, yes. So, you know how you got that ratio 1 is to root 3 is to 2?
Correct.
How did you get that?
Oh, we did that in one of the first classes. I urge you to watch the recording, but I'll just quickly do it for you. Let me just finish this question and then I'll do it quickly.
Yeah.
But again, I urge all of you to go through the recording because this is something I've already done. I don't want to necessarily repeat basic stuff which is already covered, so that we can march forward ahead. But that said, Ranveer, no problem. I'll just do it again. Okay, so where are we? Right now we are at 10 root 3 by 3 is the radius of this is 10 root 3 upon 3. And now what's the question? What is the circumference of the circumcircle? So it's just 2 pi r. So 2 pi into 10 root 3 upon 3. You can leave it in this form, right? Unless obviously the choices will be there in the exam, right? So I didn't want to give choices so that you guys don't guess, right? So 20 pi root 3 upon 3, right? So now 2 things. Okay, first let's do Ranveer's question. Why is it 1 is to root 3 is to 2 and a 30, 60, 90? Let's do that. So if I have a 30, 60, 90, so let's say this is 30. I mean, the side opposite to 30, I mean. Right? Now, I'll draw a symmetric diagram below this, which is same 30, 60, 90. Ranveer, you with me so far? Okay, so right now, I don't know it's 1 is to root 3 is to 2. I only know, let's call this length as x, right? Because I've symmetrically drawn this below, this is also x. And because this is 30, and because this is 60, and because this is 90, and because this is a reflection, this is also 30 here, and because this is also 60 here. Okay, now the full big triangle is an equilateral triangle. So if this length is 2x, this also has to be 2x, and this also has to be 2x. Right, Ranveer? Yeah, you can just use your thumb also just to show. Okay, the electronic thumb. Okay, now this is x and this is 2x, and now it's fairly easy, right? So this missing side will be square root of 2x whole square minus x square, which is square root of 4x square minus x square, which is square root of 3 times x. So this becomes root 3 times x. Hence the ratio of 1x is to root 3x is to 2x. Make sense, Ranveer? Yeah, okay, good, cool. Now, the other thing I was commenting was in a right triangle, the circumference, the circumcircled radius, right? What did I say? My observation is, so in any right triangle, let's say this is of length A, doesn't have to be 30, 60, nothing, right? So in any right triangle, so let's say this is small a, and this is small b. So let's say this is capital A, opposite to this is capital B, this is capital C. So we know C is square root of A square plus B square. Now, what am I claiming? I'm claiming that R, which is the radius of the circumcircle, which is ABC by 4 delta. In a right triangle, I'm claiming it's square root of A square plus B square by 2 in a right triangle. Okay, let's check if that's true, right? So this is general. This is general for any triangle. So specifically for a right triangle, why does this property hold? Let's see. So ABC, I'll just replace everything in terms of small a and small b. Small a, small b, and small c is nothing but square root of A square plus B square. And then 4 delta. What is delta? Area, which is half into base into height, B into A. So we have the A and B nicely cancelling out, 4 and 2 nicely cancelling out. So we get square root of A square plus B square upon 2, which is exactly half of the hypotenuse. And therefore, the circumcircle center will fall here. And therefore, this measurement, T, this is small c, or let's say this point is D or something, right? So DC, DB, and DA will all be equal in length, right? In fact, if you further extend it, so one thing leads to another, right? So if you further extend it, and complete till here, and sorry guys, this mouse is okay. Now if I complete this rectangle, you will see that I'm able to draw a circle which is around the rectangle, right? I'm able to draw a circle. I didn't draw the rectangle well, but I should be able to complete a circle around this rectangle, right? And we will come to that, right? Such a quadrilateral which is encompassed within a circle is called a cyclic quadrilateral. I'm getting ahead of myself here, but we'll make a reference later, right? Okay, a quadrilateral which is exactly snugly sitting in a circle is called a cyclic quadrilateral. So a rectangle is a cyclic. You're able to draw a circle around it. Okay, anyway, we'll come to that point. As far as this problem is concerned, the circumcircle center falls at the midpoint of the hypotenuse, and therefore the radius is half of the hypotenuse. Okay, all right, let's move on. Question, yeah.
So how do you find the area if it's not a right angle triangle?
Yeah, then you have to resort to Heroin's formula or something, right? Square root of
root of S bracket.
S minus A, S minus B, S minus C.
Okay.
Yes, correct. Or some other information might be there. Yeah, right. So there'll be something for sure to calculate. Okay, that was question 4. Question 5. Hypotenuse of a right angle triangle measures 481. The other 2 sides are integers. Find one possible set of values for them, right? So now only this information is given. Now, if you recall the property of the Pythagorean triplets, so I've told, right? So I've told this could be, you remember, this could be any odd number like 2n plus 1, right? Example 7, right? Right? And then this guy, the other 2 sides, so 2n plus 1, and then if you square 2n plus 1, okay. The other 2 sides, if you recall, okay, I'll take this example itself. 7, 49 is the square of 7. 24 and 25 are almost 2 equal halves. That will form a triplet, correct? So exactly same concept. We know that the hypotenuse is 481. Hypotenuse is 481, which means this guy is 480. Is one possibility. I'm not saying this is the only possibility. One such possible easy right angle triangle is when these are successive numbers, 481 and 480. 481 and 480, when you add, you get how much? 961. And 961 has been, if you recognize, it's 31 square. And therefore, this guy is 31. So 31, 480, 481 is a right angle triangle, right? And
so I'm confused as to how you got the how you got the 7, 24, 25. Like, I know that's a triplet, but then how do you relate that to the question?
Did you watch the recording from last class, Drishit?
Yes.
The Pythagorean triplets towards the end.
Yeah.
Okay, so can you tell me a triplet which starts with 13?
Wait.
What is the first step you will do to calculate a triplet, to find a triplet that starts with 13? You'll square it,
Yeah, it's square. Yeah.
169, and then you'll split it into almost 2 equal halves. So 84 and 85, correct?
Yeah.
Now in this problem, this last guy was given, 481 was given, this was not given, this was not given. So I did this 480. And then
Oh,
I added these two. I'm reverse engineering. And therefore I'm implying that this is 31.
okay.
Does it
So
make
you can
sense?
do this with essentially like every
Yeah, not always it will work out, right?
Yeah.
I've given the problem such that instead of 481, had it been 491, it won't work out, right?
Yeah.
When I do 491 plus 490, it won't be a perfect square. 981 is not a perfect square.
Yeah.
But I framed the question such that it will work out.
Yeah.
Right?
Yeah.
Yeah, makes sense. And again, so main point is when you see 9, it should not be a random number for you. You should know all perfect squares till 1000. Immediately chamakna chahiye 961, I know it's 31 square, right? Only then all of this is of value, which is why I keep harping, know all your perfect squares, know all your perfect cubes, know all your powers of 2 and powers of 3. When I say all, at least till 1000, right? I'm not asking for the moon here, right? Make sense? Like I repeated, right? Given a 31, you can easily square and say it's 961. But given a 961, recognizing it's a square of 31 is important. 961 is one example. In general, I'm saying. Okay, that was question 5. Okay, so question 6 is an interesting one. Okay, did anyone, does anyone have an answer on question 6? Anyone was able to do this and get an answer? Arya, did you do question 6? Arya.
No, I didn't get this one.
Okay, Navya, did you? What did you get on this one?
I got 4/3, 7/3.
4/3, 7/3. Okay, let's check. Anyone else with matching her answer or a different answer?
Yes, I got the same answer.
You got the same answer. Okay, so very likely it's right then. Okay, let's do it. Okay, so on the x-axis lie points C and D with coordinates small c and small d. Right? If point P is such that CP is to PD is M is to N, then the coordinate of P is given by this blah, 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 this expression. Okay. Now, the problem starts after here using this general information. So right now, I'm just giving you general story. What is the general story? If I have an x-axis, if I have some line, doesn't even have to be x-axis. And if 2 particular points are given, right? So this is C and this is D. Right? And always replace with some numbers so that you get an idea. And CP is to PD is, let's say, I don't know, 2:5, right? 2:5. And no one is giving that, but I'm just saying, just so that you understand what's happening. So suppose I taught 2:5, it will be something like this, right? So this is 2:5 will fall somewhere here, let's say. Okay. So this is CP is to PD is 2:5. Now, the coordinates of P are given as n times C, okay, which is, so this is the coordinate, which is C, and this is the coordinate, which is D. So C and D are numbers. So I'm saying the coordinate of this is.
So how did you get 2/5? 2 ratio?
No, I'm just saying, just for example, just to illustrate with an example so that because otherwise too many variables is easy to get lost, right? So to understand anything, put some sample numbers and see for yourself kya ho raha hai. That's all I'm saying. Right? So this is 5 times C plus 2 times D upon 7. Right? Now, does this make sense? Why should there be more bias towards C? It's in other words, C has more, you're dividing by 7, which is like normalizing, right? But you're doing 5 parts of C and only 2 parts of D. And that makes more sense because the point P is closer to C than to D. It's only 2 units away, or rather ratio of 2 parts away from C, whereas it's 5 parts away from D, which means the coordinate of small p should look more like coordinate of C and less like coordinate of D. Does this make sense to everyone? Does this make sense? It's more aligned towards C. For example, in fact, let me take a more extreme example. Let's say this M is to N is not 2:5, but let's say it's 1:100 or 1:99. Let's say 1:99. Okay, so if it's 1:99, then this expression will become 99C. So the point P will lie somewhere here. right? And I'll say the coordinates of point P are 99C plus 1D upon 100, which means approximately, not approximately, it's 0.99C plus 0.01D. So it's a mixture of C and D, but majority of that mixture is C and very little of D. And that's to be expected because the point P is 100 times closer or whatever, right? So much closer to C than to D, which is why this expression, the ratio is ulta, N times C and M times D. It's ulta, right? Did I confuse you guys more, or you guys getting the intuition on this?
No, sir, got it.
Got it, right? Suhani, you're okay? Okay, now back to this question. So this is general information of how the splitting ratio works. Now in this particular problem, this is true for any line, doesn't have to be the x-axis, right? Doesn't have to be any line. So in this problem, okay, find the coordinates of the centroid of the triangle PQR whose coordinates are given. So let's draw a triangle PQR. Let's draw the axis first. So this is y-axis.
So instead of 1 raised to 99, why wouldn't you give 99 raised to 1?
We can, right? It'll be closer to D. It's not 1 raised to, it's 1:2. Not 1 raised to, it's 1:2 ratio. Yeah. If you say 99:1, the coordinate will be, so in that case, it will become 0.01C plus 0.99D. It will be closer to D. Does that make sense, Yuvam?
Yes, sir.
Yeah. Again, just 2 examples just to illustrate. Yeah, it can be 99:1 as well. Okay. Now, okay, let's erase this. Right? Let's focus on this triangle now. The coordinates of the triangle are given to be -30. So -30 is sitting somewhere here. Okay. And then this is P -30. And then Q is sitting at 2,7. So 2 is somewhere here, 7 is somewhere here, let's say. So 2,7. And then 5,0 is somewhere here, let's say. This is R, 5,0. Now, I want the coordinates of the centroid. Centroid is what? Meeting points of the medians. So this is the median, this is the median, this is the median. So this point is the centroid, typically denoted by capital G, right? Capital G. And now I'll let out the climax even right now itself. It is an easy formula for the centroid, right? And that formula is, it's just the simple average of the 3 x coordinates. And likewise for the y coordinates, right? I haven't told you this. Now I'm telling you this. Otherwise, you would not do this hard work of calculating this and you'll miss out on this learning of MS2N. Now, what is just first, let's check if Navia's answer and whoever else has got the same answer. Let's check whether that makes sense, right? So -3 is the x coordinate of the first one. 2 is the x coordinate of the second one. 5 is the x coordinate of the third one. If I do this, I get how much? 5 plus 2, 7 minus 3 is 4. 4 by 3 matches. And if I do the average of the y coordinates, it's 0 plus 7 plus 0 by 3, which is 7 by 3. That also matches. So that answer is right, Nadia. Sorry, who else got it, you said? Was that Adya? Aram, yeah. Okay, cool. Okay, now, without knowing this formula, of course, we'll check whether we'll get the same answer, right? The main learning in this problem is 2 learnings. One is eventually knowing this average formula for centroid. Other one, how to split any line in a ratio MS2N. That's more important, right? Now, median means what? It will exactly divide in the ratio 1:2, right? So you know that, okay, let's first draw the triangle PQR. So this is P, this is Q, this is R, right? And median is exactly dividing this into 2 equal halves. So this is the median. Okay, so this and this are equal. Okay, so the coordinates of the median is fairly easy. And the coordinates of the point, let's call this S. S is fairly easy. It's just a simple average of the 2 coordinates, right? In fact, even if we didn't know that, we can do this, apply this formula. So the ratio is 1:1. So if it's 1:1, the coordinates of the point will be 1 into -3 plus 1 into 5 upon 1 plus 1. Which is just a simple average. So 5 minus 3 upon 2, which is 1. So the coordinate of S is 1, 0. So you know the coordinate of S now, which is the simple average of the 2 points. But you did not even need to know this MS2N. We all know by intuition, midpoint is just the average of the 2 coordinates. Now, the other thing you learned was the centroid which will be the meeting point of the medians, will divide the median into ratio 2:1. So we went over that last class. So QG is to GS will be 2:1. Now, this is what we are going to apply to find the coordinates of G. So I know my Q is 2,7. I know my S is 1,0. Now I'll have to apply this 2:1 ratio both to the X coordinate and to the Y coordinate separately. Okay, so let's apply to the X coordinate. So the X coordinate here is 2 and the X coordinate here is 1, but the ratio is 2:1. Therefore, it's 2 times 1 plus 1 times 2. Are you guys with me? So maybe, so just imagine this is on a plain line like this, QS, and G is sitting somewhere here. Unfortunately, the numbers are all colliding, 2 and 1, right? So they mean different things. So this ratio I'm saying is 2:1. So how would you divide it? You will take 1 and multiply by the coordinate of the X coordinate of Q, and then upon 1 plus 2, which is 3. So you get your 4/3. When I illustrate with the Y coordinate, it'll be a lot clearer because there are too many 2's and 1's here. It's a little confusing, right? Let's do with the Y coordinate. Y coordinate here is 7. Y coordinate here is 0. How will you find? In the ratio 2:1, you will do 7 multiplied by 1 part. You will do 0 multiplied by 2 parts. Now you'll tell me, why do I need to multiply 0 by? I'm trying to illustrate how this works, right? Tomorrow, if it's not 0, something else, it'll matter. Divided by 1 plus 2. That's how you get the coordinate as 7/3 for the Y coordinate. Doesn't make sense. 4/3 for the X coordinate and 7/3 for the Y coordinate. Okay. Now, so yes. What, Drishit?
So why did we even need the like C coordinate and the other one?
Which C coordinate?
It's like sorry.
Oh, this one, the initial information, right?
Yeah.
For you to know this formula. So I said,
Oh.
right, using this general information, which means so far whatever I told you is not connected to this problem, but you'll use this information for solving the rest of the problem.
Yeah. Okay.
Right?
Yeah.
So C and D have nothing to do with this question. This
Mm.
triangle is PQR. This triangle is some random, some point C and D on the number line. Everything clear on this? All okay? Arav, are okay? Aditya? Okay. Cool. That was question 6. Question 7. Okay. I think some of you had messaged me also on question 7. I thought we'll discuss in the class. If the perimeter of a triangle is 30 and each side is given to be an integer, how many different triangles could be drawn? Okay. Perimeter of triangle. If the triangles are congruent, they are counted as same, right? Counted as 1. What do you mean by this? For example, the sides could be 12, 10, and 8. In another triangle, I could have them as 8, 12, and 10. I'm saying whether you count it this way or this way, don't double count them. I'll treat them as same. First, understanding the question is important. So calling 12, 10, 8 as one triangle and calling 8, 10, 8, 12, 10 as another triangle is wrong. I mean, wrong, not wrong. I'm saying for this problem, the definition of the problem states that they are to be counted as one same triangle. Okay, right. Now, which of these has, sorry, first of all, I'm saying how many different triangles are possible? How many different triangles are possible? Okay, so let's go with a systematic approach of counting the triangles, right? So let's divide into 3 parts. We'll count equilateral triangles, we'll count isosceles triangles, and we'll count scalene triangles. Again, this is not the only approach. There are multiple ways to approach, right? Sorry, ignore my handwriting. It's horrible. Scalene, I'll just say SCA, scalene. Okay, equilateral is easy. There's only one, 10, 10, 10. Okay, matter khatam, right? So only one. Okay, so I'll just put the total count here, 1. Okay, isosceles. Isosceles means 2 sides should be same, and the third one is different, right? So I can start with 1, 1, and 28. Sanvi, will this work? Isosceles? Sanvi, you're there?
Sir, it can't really be a triangle because the sum of 2 sides has to be greater than the third one, right?
Excellent. You did not fall for the trap. Good. Right? 1, 128, even though it adds up to 30, is not a triangle because the sides have to add up to bigger than the third side. So 1, 128 will not work. Well done, Sanvi. Okay. So So 1, 1, 28 will not work. Similarly, by that logic, nothing will work. If you do 2, 2 and whatever, 26, that will also not work. Until unless this guy has dropped down to below 16, right? Only if it's below 16, the other two are adding up to more than half, right? So again, you don't need to write all of these to, right? If you know it, that's good, right? So I'm doing this in detail so that you don't do this mistake, right? So all of these is ruled out. So effectively, you're starting with 14 only, and these two sides being 8 and 8, right? Now I can count it in a different way, right? 8, 8 and 14, which means 9, 9 and something else, 10, 10 and something else. I don't want to waste time writing out this number, right? So what is the point? I'm only asking for the count, right? So I don't need to write the numerical value. I'll keep going, 11, 11, because it'll take 2 seconds to calculate. Why bother when it's not needed? I want to be as lazy as possible. 12, 12, 13, 13. Even this, I'm listing out. I'll just directly go. So in the exam situation, like Sanvi, I would have immediately realized 1, 1, 28 is not possible. In the next 1 second, I'll realize 8, 8, 14 is the first. And then I'll put a dot, 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 and see the pattern. I'll say 14, 14, 2 should be the last. And then I'll count from 8 to 14. Aditya, 8 to 14, how many triangles?
So can you hear me?
Yeah, how many?
So 7.
7. Good. Thank you again, not for falling the trap. Falling into the trap. 14 minus 8 is 6. But then always plus 1, right? When you're counting numbers from any point to any point, it's the difference plus 1. Right? You can literally hand count and see for yourself. 8 to 14, there are 7 of them. So there are 7 such isosceles triangles. 7 such isosceles triangles. Yeah. Okay. Yeah, 15, 15, 0 is not possible, right? Okay. Now isosceles is covered. So I'll put this 7 here at the top. 7. Yeah, Arya. Yeah, go ahead, please.
But 10, 10,
Arya,
and then
doubt.
it will be 10. It will be 10, 10, 10, which is not isosceles, it's equilateral.
Yeah, I've counted it here. 10, 10,
Yeah,
10.
so,
Yes.
but you've counted it in 8, 9, 10, 11, 12, 13.
Wonderful.
14.
Made it. Good point. Good point. Very good point. Very good point. Yes. Right. Therefore, this should be 6. Thank you. Okay. So 6 plus 1. Okay. Again, you don't need to necessarily split like this. I would have either done either scalene or not scalene. And not scalene, you would have got this 10. Oh, sorry, 6 plus 1, which is 7. Yeah. Very good point. So scalene. So scalene, it's a little safer because I want to make sure that A is greater than B, strictly greater than B, strictly greater than C. Right? So I can emphasize this more strongly here. Now, obviously, the longest side has to be less than half of the perimeter, which means A has to be strictly less than 15. A has to be strictly less than 15. We all agree, right? Because again, just to repeat, if A is more than 15 or even 15, then B and C are adding up to only 15, which won't form a triangle. The B and C, the smaller side, should add up to more, strictly more than the longest side A. Right? A is less than 15, which means my starting number itself can be 15, 14 and balance change. Whatever that changes, I don't care. 15, 14 and change, right? I want to make sure that, not 15, 14. 14 it has to be less than 15, right? So 14, 13 and change. Okay. Now, it can be 14. I'm saying change because I don't want to calculate what that number is. Okay, fine. For one of them, I can calculate, right? So that I know the pattern. So 14, 13 and 3, 14, 12 and 4, right? Now, this 14 series will end when these two are almost equal, right? So the balance is 8 and 8, but I want this to be bigger than this, right? 9 plus 7. These two should add up to more. These two, the B and C should add up to 16. So I can keep going from 13, 3 all the way till 9, 7. So how many of these? We can either count, I'll put a dot here, right? So 3, 4, 5, 6, 7 is 5 numbers, right? So there are 5 starting with the 14 series. I'm done with the 14 series. 14 series meaning the longest side being 14. Next is the longest side being 13. So if this is 13 and this is 12, in other words, these two should add up to 17 now. So we'll start with 13, 12, 5. You can just write 1 or 2 to see the pattern, and then you'll know where to finish. The last one, these two should add up to 17, right? And the B must exceed C. So this is how much? 5, 6, 7, 8, only 4. When you do one more, you'll see the pattern for yourself. So this is 12, 11. So these two should add up to 18 now. So it will start with 11 plus 7. Right? And then this will keep going on till this is adding up to 18. But this should not be equal, right? And that's it. Am I right? Oh, this is only 3. I'm sorry. This is only 3, right? Oh, 4. Yeah, no, it is fine. Okay. So 12, 11, 7, 12, 10, 8, 12, 9, 9 is not to be included because we want B to be greater than C. That's already counted in the isosceles series. The 12, 9, 9 is already counted in the isosceles series. It was sitting somewhere here. This 12, 9, 9, 12. 9, 9, 12 is already counted. The same as 12, 12, 9, 9, right? So this is, so how many do we have? We only have 2 here. 12, 11, 7 and 12, 10, 8. So only 2 here. Okay. And then keep going. We'll very soon reach the end, right? So 11 series, this has to be 10. This has to be 9. So there's only 1 here. Did I overcount here? This is 1, 2, and 4 and 5. There's no 3, is it? Yeah. That's surprising. 16. Yeah. Again, so systematically we are counting, right? If we are not making any mistake, we are starting with A greater than B greater than C. We are finishing off the 14 series, then going to the 13 series, 12 series, 11 series, and we are done. Because we cannot have 10. If you have 10, then obviously it has to be less than 10, which is 9. And then the third one has to be even less than that. How will it add up to 30? So we are done. Now we just have to count all of these and say what the count is, which anyone can do, right? 5 plus 4, 9. 9 plus 2, 11, 12, plus 17. Total of 19 triangles. Did anyone get 19 or close to that number? Maybe either with some mistake. 19 is what I've got. Ranveer, did you do this problem or were you able to complete it or halfway through?
Oh, wait, so can you say that again? Sorry.
No. Did you get a concrete final answer on this question? Or did you?
No, not really.
Okay,
well-
but do you understand this method fully?
Yeah, kind of. Yeah.
How to
not sure.
systematically count? Okay, all right. Now the next question is, which one has the maximum area? So this is a little difficult question to do it like one by one, right? But in general, whenever the general rule, whenever the perimeter is same, right? A shape which is more uniform will have a higher area. Okay, so what do I mean by that? Let's say I'm given a length of wire which is 100 centimeters. Now, suppose I can build any shape I want. I could build a triangle, right? I could build a scalene triangle, right? I could build a trapezium. I could build a rectangle. I could build a square, right? I could build a weird looking pentagon, right? I could build a proper pentagon and so on, right? I could build a ellipse. I could build a circle. Now, between any two pictures, whichever is more symmetric or right, more symmetric will have a higher area. So between, again, under the constraint that all of them have the same perimeter. So between an equilateral triangle and an isosceles triangle, the equilateral triangle will have a higher area, right? Now, between a trapezium and a rectangle, I would say a random trapezium, let's say random quadrilateral and a rectangle will have a higher area. And between a rectangle and a square, the square will have a higher area. Again, with the same constraint that the perimeter has to be 100. So for example, let's construct a rectangle. The square is 25, 25, 25, 25. That's easy. You can construct a rectangle of 30 here and 20 here, 20 here and 30 here. Let's compare. 30 times 20 is 600, whereas 25 square is 625. So the area of a square is higher, right? And suppose construct an equilateral triangle and you want to compare with a square. Both are symmetric. So this is a symmetric 3-dimension. This is a symmetric 3 sides. This is symmetric or regular 3-side, and this is regular 4-side polygon. Regular 3-side versus regular 4-side polygon. The regular 4-side polygon will have a higher area because it's more circular, right? And I can just verify this. This is 33. I mean, it's difficult to do by hand, but if I actually do root 3 by 4 side square, if you do this on this, you will see that that area comes out to be less than the square area of 625. And similarly, the same logic goes. A regular pentagon will have a higher area. The one which has the highest area will be a circle. So given you want 100, given you have a 100 centimeter wire, suppose you have to draw a shape that encompasses the highest area, you should draw a circle with the perimeter 100. Okay, more circular it is or more regular it is, it encompasses a bigger area. Conversely, for a given area, right, the more circular it is, it occupies, it consumes less perimeter. So given I have a certain area, and if I have to build different shapes, the circular area will have the least perimeter. Okay. All right. Now back to this question. It's all triangles. So the one which will have the highest area would be the 10, 10, 10 wala equilateral triangle. And even though the actual area itself is not asked, all of you know 3 by 4 into 10 square. If at all that's asked, it's 25 root 3. 100 by 4 is 25. Okay. That was question 7. Question 8. Yeah, question 8 also I got 1 or 2 pings on this. Thought we'll discuss in class. As long as you attempted, it's fine, right? Should have struggled. I mean, struggle meaning either you should have got it or you should have thought through it quite a lot, right? Not just look at it and then come to class. Oh, why am I not able to paste this now?
Sir, can you hear me?
Yes, I can hear you. Go ahead. Oh, Veer.
Okay.
Oh, awesome. For the first.
Yeah, I
first time I'm
solved
able to
it.
hear. Oh, great, Veer.
Yes.
Okay. What is the answer you got on this one?
Yeah. My ratio was 5:12.
5:12. Okay. Anyone got the same answer or a different answer, or
Yeah, I got
Sir, I got a different answer.
what was yours?
1�6.
Don't say raised to. 1:6.
1:6. Sorry.
1:6. Okay. No, that's fine. Okay. Ratio of one trapezoid to the area of the inner triangle. Okay. 1:6. Okay. Let's check. Let's do it. What is it, Navya? I didn't understand.
I also got 5:12.
Yeah, you told me. So 2 people got this, 1 person got 1:6. Okay. All right. So equilateral triangle is placed inside a larger equilateral triangle. So okay, the side length of the inner triangle is 2/3 of the larger triangle. So he's only talking about ratios here. So I can assume anything. I can assume this is 2 and this is 3, right? Center roots. Okay, but then if I do that, then the balance would be 1 and therefore half and half here, right? To the extent possible, I want to avoid fractions. So let me just, nothing wrong with this. I'll go with the bigger number. Why should I be conjugacy with numbers, right? I'll take bigger numbers like 4 and 6. So that when I complete this, the balance 2, right? 6 minus 4 is 2, can be consumed as 1 and 1 here. Okay, now what is the area of the trapezium? Area of a trapezium, what is the area of a trapezium? Is the average of the, in fact, I'll just draw a general trapezium like this, right? Of a general, forget this problem. In general, if I have A and B, and this is the height, right? Area of a trapezium is height times average of the 2 bases. Okay, and this works in the extreme case also. Forget this problem. I'm just teaching you general stuff. In the extreme case, the trapezium can go to a triangle, as in the top A can vanish to 0. The small b is here. It's the same height h. Then also it works, right? H times 0 plus b by 2. So it's half into b into h, which you know from kindergarten, right? So the area of this triangle is half into b into h. Area of a trapezium is h into a plus b by 2. It works in the other case also, as in if the trapezium slowly becomes more uniform and becomes a rectangle, right? So this is A, but nothing but B. A and B are same in this case. Then the h times A plus B by 2 will become h times B plus B by 2, which is B into h, which you know all too well. That's the area of a rectangle. So a trapezium is, or rather a rectangle is a special trapezium. A triangle is also a special trapezium. And the formula is h times average of the 2 bases. Right. Now, in this case, I know the 2 bases are 4 and 6. I know how to do average. The only thing that's missing is the height here. Right. And now 30, 60, 90 to my rescue here. If I expand on this one and draw a bigger portion of this one, right? So this portion, this is 1. And this is my 30 degree. I can see a 30, 60, 90 here, right? Because everything is symmetric. I can easily look and visually you can see it's 60. Right? Of course, you can sit and prove, but you don't need to all that, right? You can just by visually, you can see everything is symmetric, 30, 60, 90. Therefore, back to the ratio of 1:√3:2. So if this is, sorry, I need to put 60 here, right? 1 is to root 3 is to 2. So if this is x parts, then this is x times root 3, and this is 2x. So in this problem, my x root 3 is 1, which means my x is 1 by root. So the height I'm seeking is 1 by root 3. This height is 1 by root 3. Okay, so the area of trapezium is this. How much is this? 5 upon root 3. 5 upon root 3. Okay, and a ratio of what to what? The trapezoid to the area of the inner triangle. Inner triangle is easy, right? Root 3 by 4 into side square. Okay, I'll just root 3 by 4 into side square. Side was 4, so 4 square. So which is 4 root 3. Right? And therefore, the ratio that I'm seeking is 5 upon root 3 divided by 4 root 3. So divide by 4 root 3. I'll just put the 4 root 3 at the bottom. So indeed, it's 5 is to 12. Well done. Okay, does it make sense, guys? And you can find your mistake later, or were able to find your spot your mistake of 1 is to 6 or something you got.
Sir, I did it in a different way.
Okay, go ahead, please. I'll find your mistake, or I'll ask someone to find your mistake.
Sir, so I subtracted the area of the inner triangle from the outer triangle,
Yes,
but I get the area of 3 trapeziums.
wonderful.
Then I divided that by 3.
Excellent. Let's do that. That's another way to do this, right? Let's do that approach. And maybe all you did was a silly mistake. Let's do that. Okay. By the way, before I erase this, is this approach clear to everyone? Okay. All right. Let me erase all of this and let's do what he's suggesting. In fact, I think that might be even better. Maybe he just did a silly mistake. Okay. So in that case, let's keep this 2 and 3 only. So this is 2 and this is 3. So the area of the outer one is root 3 by 4 into side square, which is this. This is the outer. Okay. And the inner is root 3 by 4 into 2 square. This is the inner, right? And what does he want for the trapezium? The trapezium is the outer minus inner divided by 3. Root 3 by 4 into 3 square minus 2 square upon 3. This is the trapezium. Okay. Now, you want the ratio of this guy trapezium to the inner. So all this root 3 by 4 natak goes away. I don't need to compute it. So I'll just focus on 3 square minus 2 square upon 3 is to 2 square. As simple as that. 9 minus 4, which is 5. 5 by 3 is to 4. You got it right. 5 is to 12. What is the mistake you want? Where did you go wrong?
Sir, I didn't take them as 2 and 3. I took them like as the bigger triangle, I took it as x, and the smaller triangle, I took it as 2 by 3x. Then I did x minus 2 upon 3x divided by 3 is equal to y, which is one of the trapeziums.
Wait, what did you take as x and what did you take as 2x by 3? The side length or the area?
The area.
If the area is that, then how can you, sorry. But he says 2/3 of the side length. The side length of the triangle is not 2/3, right?
Oh, yeah, now I got it.
Does it make sense?
Yeah.
In
s-
fact, yes, go ahead, please. Yeah.
Yeah. I solved it in a different way. I solved it graphically. Would that method be okay in
Perfectly
terms
fine.
of
Perfectly fine. Go
so,
ahead.
yeah, so
explain
I
the graphical
divided
method.
each into so we know that the side length of the inner equilateral triangle is 2. So we know that it must be made of 2 equilateral triangles on the base, which means that 4 equilateral triangles of side length 1 are used to construct the inner one.
Okay.
And thus,
So,
following the format, we know that 9 equilateral triangles will be used to form a 3.
hold on just
So-
1 second. So just so that I understand.
So we
you- just so that I understand, you drew something like this, right? And
exactly.
and then you said this,
Exactly.
and then you said this length is 1, this length is 1, this length is 1. Okay, go on, please. And then what
Yes.
did you do after that?
Okay, then I said that for the outer one, there are 9 similar triangles that are used to construct it. Thus, the difference must be 5 triangles, and that 5 triangles is distributed into 3 trapezoids.
Excellent.
Right. So thus we
Excellent.
get the form 4. So would that work in terms of like a universal method, or is just applicable to this sum?
It'll perfectly work. Okay, so an extension to the problem where I could have given would be, so let's say it's not an equilateral triangle. Okay, let's do Weir's approach. What Weir is telling is, what he's suggesting is not even just for equilateral triangle. So let's say I have a scalene triangle like this. Okay, and I have another scalene triangle which is sitting inside this. Okay, and now it's good that you bringing this this approach. It's very useful, right? Now, suppose I'm framing a new question. I'm giving you. Okay, so this is ABC, and this is PQR. So suppose the problem says ABC is similar. Similar is like this, right? This is congruent. This stands for congruent, which means the shape and the size must be same. This stands for similar, which means the shape is same, but the sizes need not be same, right? ABC and PQR. If they're similar, now, what do you mean similar? There's a scale factor. Take one and you raise it up by 3 times or bring it down by 10 times, you get the other shape, right? So that's what similar objects are. They have a scale factor. Now, in this problem, I can say PQ is to AB is 2:3, right? Which means the scale factor is 2:3 or 3:2, depending on which way you look at it, smaller to bigger or bigger to smaller. Then, as an implication of that, what will happen would be the area of the triangle ABC versus the area of the triangle PQR will be in the ratio. Okay, I'll say 3/2, so that it's consistent, right? So I'll just say A by B is AB by PQ is 3:3, 3:2. The bigger one is to smaller one is 3/2. Then the area ratios will be 3/2 whole square. Right? So what do I mean by this? If in the linear dimension the ratio is 3:2, in the area dimension, which is right the square dimension, the scale factor square will be the ratio of the two areas. Right? And you can extend it to a third dimension as well. Suppose you can just form a 3-dimensional object, which will again be in the same ratio 3:2. The volume of the bigger container will be to the volume of the smaller container will be the ratio 3/2 whole cubed. Okay, so in summary, if the scale factor is k, then the ratio of the areas will be k square. The ratio of the volumes will be k cube. I think Aditya, I covered this. One of your doubts from IPM was this, right? I remember. Yeah? Okay, so you remember this now, right? So back to this problem now. What he's doing is he did not even have to split into 2 equal, right? If this is 2 and this is 3, then straight away he knows the ratio of the two areas is 4:9, and therefore the difference area would be just 5 parts. So let's say this is 4 square units. The inner part, the outer part is, let's say, 9 square units, the total bigger one. Then the difference between these two will be the 5 square units, which will be the inner, which will be the pathway which is in between. Of course, in this diagram, I cannot do divide by 3 because the 3 regions are all of differently. Even though they add up to 5, it's not like each of them adds up to 5/3, 5/3, 5/3, right? But suppose the question were something like this, and the ratio of the inner triangle to the path which surrounds the inner triangle, then the ratio would just become 5. Would just become 5:4 in that case, or 5:12, depending on the path to the outer triangle or something. You understand the 5:9 or 5:2, depending on what the question is. You understood what I'm talking about, right? The area of this guy is 4 square units. The area of the outer guy will be 9 square units. And how do you get the 4 and 9? Just simply squaring the scale factor of those two. Wonderful. All methods are good. Okay, cool. Anything else? If not, we'll go into quadrilaterals, right? Okay, so yeah, sorry. Okay, I thought there was a question. Okay, so quadrilaterals, let's first understand the sequence of quadrilaterals, right? So let's say I have a random quadrilateral like this. Okay, now the first special quadrilateral is a trapezium. A trapezium is where sides are parallel, right? Or we have one pair of opposite sides which are parallel. It doesn't talk about the second pair. The second pair may be parallel, may not be parallel. So if the second pair also happens to be parallel, right? So if I have to draw a family diagram, right? The second pair also happens to be parallel, then you get a parallelogram. So parallelogram is a special trapezium, right? This is also parallel. This is also parallel. Parallelogram is a special trapezium. Okay. On the other hand, from a trapezium, I could go to an isosceles trapezium. So maybe I'll just change colors here. I don't want to use the same thing for everything. Isosceles trapezium. An isosceles trapezium is a trapezium where the base angles are equal. Base angles are equal. Such a trapezium is an isosceles trapezium. And if a figure is both, so let's say in the family diagram, it's going like this, right? So this inherits from this, right? And something that's both an isosceles trapezium and a parallelogram is a rectangle. So if you look at rectangle, it has the properties of both a parallelogram, as in both sides, parts of opposite sides are parallel. It also has the property that the two base angles are equal, namely 90 and 90 in this case, right? On the other hand, for a random parallelogram, these two are only supplementary. Let's say this is 70, this will be 110. They'll be supplementary. In the case of an isosceles triangle, they'll be equal. If this is 70, this will be 70. The only number which is both supplementary and equal is 90, 90, and that is called a rectangle. So this is 90, 90, 90, 90. 90 and 90 are both supplementary as well as equal, which is why you get this rectangle. Okay. Now, on the other hand, from a parallelogram, I can go and say I'll make all the sides equal in length. Then I'll get a rhombus. Okay, so let's use this. I'll get a rhombus. Okay, rhombus. Okay, so all the sides are equal. So rhombus is a special parallelogram. And of course, if we have something that's both a rectangle and a rhombus, then you get the perfect shape, which is a square. A square is both a rectangle, as in the adjacent angles are equal and supplementary. And then it's also a rhombus. The adjacent sides are all equal in length, and therefore you get a square. And then you also have a kite, which is sitting somewhere, I would say here, right? A kite is not a trapezium. So kite is a figure where you have two pairs of adjacent sides being equal, right? Two pairs of adjacent sides being equal. So this is something that inherits from a normal quadrilateral. At the top level, you have a kite as well, just like with trapezium. Now, a rhombus is a special kite. So this guy will go from here also. Why is it? Because a rhombus expects all four sides to be equal. But the kite only requires there are two pairs of equal sides, right, which are adjacent. So that property is satisfied as far as rhombus is concerned. A rhombus is a special kite. Does this make sense? Is this entire family structure very clear to everyone? Right? Now, what are the main properties you should be aware of in each of them? In a parallel, so whatever property is true for a parent, I don't even have to talk about it for a child. It automatically goes through. For example, in a square, I don't have to say the sum of all the angles adds up to 360, because that property is true right to the great grandparent, which is the quadrilateral itself. All the angles add up to 360, right? So sum of all the angles in a quadrilateral add up to 360. More generally, sum of angles in a n-sided polygon will add up to 180 times n minus 2. So sum of interior angles of n-sided polygon Okay, 180 times n minus 2, which is why in a triangle it adds up to 180 times 3 minus 2, which is 180. And in a quadrilateral, it adds up to 180 times 4 minus 2, which is 360. So sum of all angles is 360 in a quadrilateral. In a trapezium, because these two are parallel, you can only say that this guy and this guy are supplementary, add up to 180. And similarly, this angle and this angle are supplementary as well. Like those are co-interior angles. You would have done all of this in school itself, right? Just a quick recap. If you have two parallel lines, if you have a transversal goes through this, then these are co-interior angles, which are supplementary. So we have two pairs of co-interior angles in a trapezium. And we cannot say anything else. There's nothing else in a trapezium to call out. Now, coming to a kite, we have pairs. Sorry, we have two diagonals, right? One of the diagonals will bisect the other. So in this case, it happens to be the longer one is bisecting, not necessarily. The shorter one can bisect the other one, but it has an axis of symmetry. It could have more two axes of symmetry. That's a different story. But bare minimum, it has one axis of symmetry, right? So which is this. So in a kite, the diagonals also are perpendicular. Diagonals are perpendicular. You don't need to say perpendicular to each other. That's redundant, right? When you say perpendicular, that's it. If a line L is perpendicular to line M, obviously line M is perpendicular to line L. You don't have to say perpendicular to each other. You'll see some of these textbooks which say they're perpendicular to each other. It's meaningless, not meaningless, redundant. But bisecting each other, that's important. It may bisect each other. One might bisect the other one. So in this case for a kite, A, B, C, D, AC bisects PD, but not necessarily the other way, right? AC bisects PD, right? One diagonal bisects the other, and both diagonals are perpendicular. Okay, that's what is a kite. Now, coming to a trapezium, in isosceles trapezium, we have the base angles are equal, and therefore the base sides are also equal. So this side will also match this side in isosceles trapezium. And the two diagonal lengths will be same in an isosceles trapezium. So this length and this length will be same. Isosceles trapezium. You can see this for yourself, right? You don't have to memorize anything. Draw a diagram, you'll see it for yourself. Whereas in a parallelogram, the diagonals are not equal, but the diagonals bisect each other. The word each other is important here because this diagonal and this diagonal, they bisect each other. This is equal to this and this is equal to this, although they are not of the same lengths. One is obviously longer, one is shorter. One common mistake that people do in parallelogram is they think the diagonal is an angle bisector of each of those angles. Not the case. For example, if you draw a parallelogram like this, it'll be very tempting to think that this is bisecting because you have drawn a parallelogram which is very similar to a rhombus, right? It looks almost like a rhombus. The base side and this side are not very far apart. If you're in doubt about a certain property, draw an extreme case of that diagram. So if I'm asked to draw a parallelogram, I'll draw a parallelogram like this, so that there's no way I can make a wrong mistake or make a wrong assumption. This way, it is very, very clear that if I draw this diagonal, this angle looks much like 20 degrees and this looks like 50 degrees, right? So the diagonal is not bisecting the angle. I can see from the diagram itself, the diagonal is not bisecting, right? But if you draw a parallelogram like this, right? It's more like a rhombus, then you can make that wrong assumption, right? And if you're not sure, is it right or wrong? Like I said, draw a diagram which is very skewed or an extreme case. Don't draw a very nice looking pretty parallelogram, which is almost looking like a square, right? True, a square is also a parallelogram, but you want to draw a general parallelogram, right? In which case you want to keep it very skewed. Okay, all right. Okay, so that's a parallelogram. And obviously opposite angles are all equal in a parallelogram. Adjacent angles are supplementary. You know all of this stuff, right? So I don't have to harp. Now, what is special about a rectangle? All the angles are 90, and therefore the two diagonals turn out to be equal in length. In a rhombus, what's more special than what you already have in a parallelogram? The diagonals are perpendicular. Obviously, they're bisecting each other because it's already a parallelogram. If it's true that it's bisecting each other in a parallelogram, it has to be true for a rhombus also. But in addition, The diagonals are perpendicular to each other, not to each other, perpendicular. That's it, right? Diagonals are perpendicular. And of course, square is all hunky-dory. Everything is true in a square, right? So this structure of quadrilateral should be very clear in your mind. And there's a special, no, there's a special family of quadrilaterals called cyclic. A cyclic quadrilateral is something where you can encompass that quadrilateral within a circle. So if I have a circle, if I'm able to draw a quadrilateral around this, like this. Sorry, I didn't draw it well, but you know what I mean, right? So this is a cyclic quadrilateral. A cyclic quadrilateral has an important property. It has a few, but the basic thing you should know is opposite angles are supplementary. They add up to 180. So if this is, I don't know, 110, then this is 70. And this is, let's say, 95, then this is 85. Right? I'm just giving some random example here. Right? Opposite angles are supplementary in a cyclic quadrilateral. It also has some other important properties, but we'll cover that later, right? As the situation demands. Okay. Now let's move on to circles. Any questions on quadrilaterals, guys? All okay on quadrilaterals? This family tree is all clear to you, or probably already was from the beginning, right? Now for one thing I have to touch on, the sum of interior angles of an n-sided polygon is 180 times n minus 2. Sum of exterior angles is 360. For any polygon, sum of exterior angles, right? Not necessarily a quadrilateral, not necessarily a triangle, not necessarily a pentagon or a heptagon or a dodecagon, right? The sum of exterior angles of any n-sided polygon will be 360 degrees. And if it's of course a regular polygon, then each one of them will be 360 upon n. Each of those external. By the way, what is an external angle? Just to be very clear. So, right, if I have a pentagon, something like this, right? The external angle is not this. This is not an external angle. That's wrong. An external angle is you extend one of those sides, and then this is your external angle. External angle. Right? That's external angle. All of the external angles will add up to 360, like I said. Okay. And the other important property is diagonals. Number of diagonals in an n-sided polygon would be n into n minus 3 upon 2. The number of diagonals in an n-sided polygon would be n into n minus 3 upon 2. Where is this coming from? Well, okay, let's say I have an n-sided polygon. Let's take this pentagon itself, A, B, C, D, E. Okay. Now I'm saying the number of diagonals for this is 5 into 5 minus 3 upon 2. Now, where is this formula coming from? If I take any one vertex, let's say B. Okay. So from B, okay, whatever I say for B counts equally good for C, D, E, and A. Right? I'm just taking B as a starting point. I can draw from B. Can I draw a diagonal to B itself? No. Can I draw B to the adjacent A? No. Can I draw from B to the adjacent C? No. These are the only three to which I cannot draw a diagonal to. So of the 5 vertices, again, imagine if there are 100 vertices, it's easy to say what is not possible, and therefore the balance is what is possible. I cannot draw a diagonal to anything. Sorry, I can draw a diagonal to anything except these 3. So the number of diagonals I can draw from B is 5 minus 3, and hence this minus 3 comes. So, and I can repeat this process for every one of those 5 other vertices, right? From B, I could draw 5 minus 3 diagonals. From A, I could draw 5 minus 3 diagonals. From C, I could draw, and so on, right? So the total number of diagonals I can draw would be 5 times 5 minus 3. But the divided by 2 comes because of double counting. Because the diagonal that I counted from B to E will get counted by B once. It'll also get counted in E's quota. But effectively, it's only one diagonal, right? It's not 2 diagonals. So E will count, it's my diagonal. B will say, no, it's my diagonal. But effectively, it's only one diagonal. So you divide by 2 for double counting. So n into n minus 3 by 2 is the number of diagonals in a n-sided polygon. Okay. Let's move on. Okay, let's go to circles. So circles, main properties. If only I can draw a nice circle here. Okay, all right. So if I take a center here, basic terminology, right? So center, if I have any chord, so this is a chord, AB is a chord. And then if I connect this with the center, if I connect this with the center, right? This portion is called a sector. A sector, right? Which is a combination of a triangle and this lower portion, which is called a segment. So sector is a combination of a triangle, whatever, I'm not writing triangle. Okay, triangle plus a segment. That's a sector. Okay, now from the center, if I drop a perpendicular, to the chord, it'll bisect the chord. You can easily prove that by one of these properties, right? SAS property or something like that, right? It'll bisect. Okay. So, and conversely, from the center of the circle, if I draw to the midpoint of the chord, that'll be perpendicular to the chord. Same thing. Essentially, it's because it's an isosceles triangle, both the altitude and the median and the angle bisector are all same, right? And the perpendicular bisector also, because it's isosceles. A is same as OB. Okay. Now, if this measurement is 2 theta, okay, or rather, I'll just say this is theta. Fine. If this angle is theta, then I can touch the triangle and come anywhere from A. Suppose from A, I go all the way till here and then come back to B. If I measure this angle at the top, that will be theta by 2. And this is true no matter where I go, touch and come. For example, I can go from A to somewhere here. From A, I can go and touch here and then come back to B. Right? That angle will also be theta. I can go from A to anywhere, right? I can literally go from here to even here nearby somewhere and then come back to here. All of these angles will be half of the angle at the center, theta by 2, theta by 2, theta by 2. Okay, you can prove all of these. I'm not taking time to prove all of these because they'll take some time, but know all of these properties for sure. Okay, now the other thing is when you have a tangent, so tangent, you all know that graces through like this, right? I'm not drawing the tangent at the base. So this is a tangent. Now, obviously, it'll be perpendicular from the center. So if I draw perpendicular from this to this, meet the center, this is 90. Now that all of us know. But what the important property you should know is if I have a chord here, if I have a chord here, right? Now this angle, suppose this is theta, then so this is the chord AB. Okay, this is 90. Now from A, I can travel to anywhere on the circle and come back to B. So for example, I can go from here to here and then come back to B. Right? This angle will also be theta. So no matter where I go and come back, it will be theta. And now that we have this diagram, if I draw from the center, if I draw to B, this will be 2 theta, of course, based on what we studied earlier. Angle at the center will be double of the angle at the periphery of the circle. Be 2 theta. Okay. And then you should also know Control 5. I have this is an important property. I'm going to discuss this, right? So if I have 2 chords that are intersecting, so I'll have one chord like this, another chord, let's say like this. Okay. 2 intersecting chords. I don't want to show them 90 degrees or anything so that you don't make that assumption. So I'll draw like this. Okay, there are two random chords. Now, if this is A and this is B, and this is C and this is D, and let's say the meeting point is P. Okay, now AP into PB will be same as CP into PD. AP into PB will be same as CP into PD. And more importantly, this property holds good even if the intersection happens outside the circle. By this, what do I mean? If I have the circle here, I have another circle here at the bottom, right? If I have a chord like this, AB, and another chord CD like this, right? So these two are not intersecting at all, right? But I can extend them. And take it outside. Likewise, I can extend this guy and take it outside. They'll eventually meet somewhere, right? So let me label the points again. Oops. Let me label the points again. So this is my A, this is my B. AB and CD are still my chords. My meeting point is still P. The same relation holds good. AP into PB is CP into PD. Don't make that mistake. Just because it's intersecting outside, it's tempting to write AB into BP. This is wrong. I'm just calling it out right away. Is equal to CD into DP. Is, you cannot imagine the number of times people have done this mistake. This is wrong. AB into BP is CD into DP. Is tempting to write because D comes in between, right? And B also comes in between. Don't do that. This is right. AP into PB is CP into PD. And this is obviously true when, not obviously true. It's obvious when things are inside. When things are outside, you should be careful. And in the extreme case, where one of those chords, one of those becomes a tangent. For example, okay, I can show it in this itself. So let's say I'm able to draw a tangent from here to here, P to T. Okay, so this is the tangent. Okay, so this is T. Then just imagine for a second that it's not a tangent, but there are two very close points here. Let's say one of them is T1, one of them is T2. We are eventually going to make sure T1 and T2 coincide and reach T. But for a second, just imagine it's like any T1, T2 is also another chord, very, very tiny chord. Then the relation would be, this is also equal to, by the same logic, T1P times PT1, right? So T1 and T1, T2 is another small chord that also is meeting this guy at P. So T1P times PT1. And then in the extreme case, if we make T1 and T2, sorry, T2. If you make, in the extreme case, if we make T1 and T2 collide into one, that's when it actually becomes a tangent. It becomes a TP into TP, which is nothing but PT square. So the square of the tangent is the product of these AP into PB. So that's a very useful relation. You'll have some diagram with some circle, some tangent and all that. Watch out for these small things, right? These are properties that get tested very often in competitive math exams. Okay, these are the main ones I wanted to cover. Anyway, we're up on time. If there's any few other topics we missed, I'll do that. And then hopefully we'll finish off number theory and a bit of statistics and probability will get started in next class. And then we'll move on after that, like elaborate topical based questions. We'll take each topic and we'll do like proper problems on them. Right now, the homeworks are little just on the surface type of problems. We'll do more deep problems. Okay, we'll Arav, you had a question? I have to go for the next one. Go ahead, please. That's a quick one.
So what is this property called?
I don't know the name of this property. I don't know whether it even has a name.
Okay.
I'll look it up. You also can wiki it and just have a look. I don't know whether it has a name.
Okay.
Meeting point of chords डाल दो बस. Okay, चलो
Okay.
bye. Thanks.
Why so?